Okay, welcome back to the week 12 sessions. In these sessions, we will learn about friend functions and friend classes. Friend functions are commonly used for overloading operators, and there are some advantages of using friend functions when you are overloading operators as friend functions. So let's learn about friends. In the previous sessions, we learned that we could overload operator as non-member functions and member functions. If we overload operator as non-member functions, we use accessor and mutator functions in order to access private members. We learned that this is not efficient because function call leads to the overhead. We can solve this overhead problem by using friend functions. Friend functions are non-member functions, but they have all the privileges of member functions. So this means that friend functions, so even though the friend functions are non-member functions, they can access private members of the class. I have already explained this in previous slides. Friend function is not a member functions, but because it has all the privileges that the member functions have, it can directly access private members. So you don't need to use accessor and mutator functions, which will improve the efficiency of your program. How can we make friend functions? All you need to do is specify friends keywords in function declarations, and you must declare the friend functions inside of the class definition using friends keywords. But note that even though the function is declared within the class definitions, it is not a member functions if you use a keyword friends. Let's look at the demo code for these friend functions. This is demo code. As you can see here, there is a class A, and it has a one private member, which is a num, and this is a constructor, and this is the friend functions. The function name is a print num, and it receives one argument type of this class A type, and we are declaring it with a friends keywords like this, and we are declaring this function within this class definition. So this is syntactically correct, and this is how you make the function friend. And this is the definitions of the friend function, because friend function, even though this friend function is declared within this class definition, this is not a member function of class A. This is non-member function. So when you are defining these print num functions, you don't need to specify the class name like this. This is not correct. If you do this, it leads to the compiler error, because there is no member function name print num. So you should not use this. You have to define the friend functions like non-member functions, and you do not use a friend keyword in function definition. You only use the friend keywords when you are declaring the functions. So and if you look at these main functions, we are creating one object and we are passing these objects to this printNum function, which is a friend functions. And if you look at this if you look at the body of this printNum functions, it's accessing non-private member variable using a dollar operator. So it's accessing private member directly. This is not possible for the non-member functions, but because this is a friend functions, you can directly access the private member like this. You don't need to use accessor functions such as a getNum. So let's compile this program and see the output. As expected, this is printed properly. Num is 10 because the default constructor initialized num with a 10 value. But assume that there is a printNum2 non-member functions. This is not a friend function because we did not declare it here. This is purely non-member functions, and it's receiving class type of A, and it's accessing A objects is private members using a dot operator. So it's accessing private member directly, and this should not be allowed. So if I compile this program again, as you can see here, compilers complaining about this line. Non-member functions cannot access private member directly like this. So this is how you declare friend functions and define friend functions and the advantage of using the friend functions. So for example, for this non-member functions, you have to use something like get num in order to fix the compiler error, you have to use something like this, get num. It should fix the compiler error. Yes. Yep. Let me call this num2. Yep. As you can see here, in order to fix the previous compiler error, you have to use an accessor like this. And now it's working. But as I explained in the previous sessions, if you use some accessor function like this is a function call, so which will degrade your program's performance. So it's not efficient. This is direct access private member is much more efficient than calling the functions. So that's one advantage of using a friend functions. You don't need to use accessor functions. So now let's go back to the slides. We just saw this demo code. When to use friend functions and what are the advantages of using friend functions? We already talked about the advantage of using friend function using a demo code. The most common kinds of friend functions are overloading operators. So friend functions are mostly used for overloading operators. This doesn't mean that you can only use friend functions for overloading operators, but the common purpose of using friend function is overloading operators. You can use friend functions for any kinds of functions. It improves the efficiency, as I explained in using a demo code. by directly accessing private members, not calling the accessor and mutator functions. And it allows the automatic type conversions. So this is automatic type conversion. Let me explain the concept of automatic type conversion using a demo code. So this code is a little bit big. So if you look at these main functions, it's declaring two class type variable, base amount and full amount. And for base amount, we are passing two arguments, 160, and for amount, we are not passing any arguments. So this will invoke the constructor which receives two types of integer values. So if you look at here, this constructor will be invoked, and that is this one. So this class has a member variable dollars and cents. So the first argument will be used to set the dollars, and second arguments will be used to set the cents. So for these objects, dollar will be 100 and cent will be 60. Here we are adding this base amount, so these objects with a 25 integer value. We have overload plus operator here as a non-member functions. So this is a standalone and global functions. So if you look at this, it receives two operands type money, and add them, add the dollar stored in these objects and cents stored in these objects to calculate new dollars and cents, and returns the new objects using this newly calculate dollars and cents. And note that because this is a non-member functions, we cannot directly access dollar and cents because they are private members. So we are using accessor functions like this, get cents and get dollar. Note that we overload plus operator so that it works with our class type money. So it's receiving two arguments type of money. But if you look at this line, it's receiving one money class type of value and one integer type of value. But we did not overload plus operators to receive the int type of value. So here 25 is not a appropriate type because we did not overload the plus operators so that it can work with combination of this money class type and the int value types. It only works with the two money class type of value. So you might think that this leads to the compiler error, but if we compile this program, let me create this one first. This compiles well. And if I run this one, it produced the expected output as well, because here the base amount is the dollar for this base amount object is 100, and because we are adding 25 to 100, it's printing the correct values. And if we add a 30, it prints the 130 because 100 times 30 is 130, and because there is a 60 cent, it's printing 60 cents. Not as expected, this program compiles well and produces correct output, even though we did not overload these operators to work with integer type. Currently, our overloaded this first operator only work with 2 money class type of value. So why this is happening? Why this program compiles well and produce correct output? The reason for this is the correct output is automatic type conversions. If your class definition contains appropriate constructor, then the compiler will perform type conversions automatically. So the process is that the compiler first checks whether plus operator has been overloaded so that it received objects of money type and an integer value, which is not our case because in our example code, it only received 2 arguments type of money class. If there is no such overloading, the compiler looks to see if there is a constructor receive a int value. So in our example, if we look at the class definitions, there is a constructor which receive 1 integer value here. So compiler will automatically invoke this constructor using the int value and automatically convert 25 to object value of type money. So if you look at the definition of this constructor, is this one. What it does is it initializes the dollars using these first arguments values and set the cents to 0. So the compiler automatically converts this int type of value to the money type of value by calling the constructor that receives 1 int type of arguments. This is the reason why the program produces expected outputs. The type conversions will not work unless there is an appropriate constructor, but because there is a constructor for receiving 1 type of value, compilers are using the constructor and convert this 25 type of value to these money types of value so that these plus operators can work because this 25 is converted into the class type of money. So this one also, same for this one as well. The compilers automatically convert this 30 int type of value to the money class type by invoking the constructor which receive 1 int type of value. This is the advantage of using non-member overloading operators, because we can control 2 arguments for the binary operators when we are overloading these plus operators. So if we overload this plus operator as a non-member function, we can control the two operands, the first operand and the second operand. So these type conversions work correctly for the member functions. But if we overload plus operator as a member functions, the type conversions can only occurs here, not for this one. Let me explain this using a demo code. Let's first remove this code. Now I will overload the plus operator as a member operators. Here I'm overloading plus operator as a member operator, so I use the class name here and only pass the second argument operands, not the first one. Note that if you overloaded operator as a member functions, the calling objects will be the first operands of these operators. So you only need to, you can only specify the second operands, not the first one. But the advantage of using this one is that for the first operands, we can directly access the private member. Cents and dollars are private members of the class money, but because this is a member functions, we can directly access this one, which improves the efficiency of the program. In the previous example, we used the get cents and get dollar accessor, but now we can directly access member function. This is the one advantage of using member functions for overloading operators. And I need to declare, to make the member functions, to make the operator, to overload the operator as a member function, you have to declare this within this class definitions. So now I've changed it. The plus operator, overload the plus operator as a member operator. So let me compile this program. Okay, so compilers are complaining about this line. So let me first remove this line. Okay, now compiles well, and type conversion, automatic type conversion occurs here properly, and the expected output comes here. But unlike the previous example, if we overloaded plus operator as a member operators, we cannot do this. If we compile this program, the compilers are throwing error here because we cannot automatically convert this integer value to this money. Here, the compilers invoke the constructor, which receive one argument, int type of arguments, and convert this 25 to the money class type of value. So this works correctly, but this one does not. We cannot convert the type to money class type. Because we overloaded plus operator as our members. So as you can see here, the first operands of this plus operators is calling objects, and calling objects is a type of this class money. So you cannot convert this. So this is not allowed if you overloaded operator as member functions. But if you make this so there is a pros and cons for using these non-member function and member functions. So if you use non-member operators, you can perform automatic type conversions for both operands. For member operands, you can only perform the automatic type conversion for the second operand, not for the first operands. But for non-member operand, non-member operators, you have to use accessor and mutator functions to access private members of the class, which is not efficient. But for member operators, you can directly access the private members. So you don't need to use accessor and mutator functions, which improves the efficiency of the program. So there is a pros and cons for using non-member operators and member operators. You can make this overloaded operator as friend functions. We learned friend functions in the previous slides. So now I'm overloading the plus operator as friend functions. For that, you have to use a friend keywords and you have to declare the overloaded operator within these class definitions using this friend keyword. And as I explained in the previous slide, even though this operator is declared within this class definition, this is not a member functions of this class because we use a friend keyword. And when you are defining a friends function, you don't need to specify the friends keywords, and you don't need to place the class name here. You cannot do this because friend function is non-member functions. So you have to define friend function just like non-member functions. So you do not specify the class name, and you are specifying both first and second operands. So member functions, member operator, we only specify the second operands because the first operand is always the calling objects. But because the friend functions, because this is a non-member function, you have to specify first and second operands. And because friend functions can access the private members of the class, so it can access the private members of cents and dollars directly using a dot operators. So with this friend function, you don't need to use an accessor and get operators. So if you look at this one, now if I compile this program again, previously there was a compiler error because we could not automatically convert this 30 to the money type of value because when we changed the operator as member operators. But now we changed the member operators to friend functions. So Now this one compiles well and produce expected output. That's because with our friend function is a non-member function, so we can control both first and second operands. So we can convert both second and first operands. We can perform the automatic type conversions. But if you look at the definition of this friend function, we are directly accessing private members, like member operators. So this does not use the accessor and mutator function, which improves the efficiency. So this is the reason why we are using a friend functions commonly for the overloading operators. It takes the advantage of non-member functions that allows automatic type conversion for both first and second arguments, and it takes the advantage of member operators, which do not need to use accessor and mutator function by directly accessing private members like this. It can improve the efficiency of the program. So using a friend function, you can take advantages from the non-member operator and member operators. Hope you understood these concepts. If you are not clear about this concept, please ask me questions through email. Okay, let's go back to the slides. In the previous slides, we learned how to make a function friend, but the entire class can be a friend of another class as well. The friend class can access private and protect members of other classes. So for example, if class F is a friend of the class C, then all member functions of the class F are friends of C. So let's see the friends class demo code. This is much simpler demo code than previous one. Looks good. If you look, there is two class A and class B. And if you look at this code, class A has a private member none, and we are making class B friends. So what this line does is that class B, it's saying that class B is a friends of class A. So class B can access all the private members of the class A. That is what this line means. So like making friend functions, you make the friend class using a friend keyword. And if you do this from the class B, it can access the private members of class A. So here, num is a private members of class A. Because class B is a friends of class A, you can access our private members just like this. Let's compile this program and see the output. This compiles well. And this prints num is 10 because if you look at the main function, we are declaring two types of class variable, and obj2 is a class type B, and we are calling this function by passing the obj1, which is a class type A, and this one is created, the object is created based on this default constructor. So in this default constructor, none is initialized to 10. So here, none is printed as 10. So this is expected output. So this is the concepts of friend class. Let's go back to the slides. One more thing, you can overload the square brackets as well, and this is known as array operators. And if you do it, then you can use square brackets with objects of classes you defined. And when you overload array operators, it has to be member functions. You cannot overload this array operator as a non-member functions. So for these statements, A is the calling object. So A will be the first arguments to the overloaded array operator, and 2 will be the second arguments of the overloaded operators. Let me show you a brief example code for overloading these array operators. So here we have a class named char_pair. It has a 2 member variable, first and second. And we are overloading this array operator as member operators. And this is the definition of the overloaded operators. So if the index is 1, it returns the first. And if index 2, it returns the value of the second members. And otherwise, it prints the error message and terminates the programs. So if you look at these main functions, we are declaring a class variable char_pair, and this will invoke the default constructor, which is this one. Okay. So here we are passing the objects. We are using this object just like an array. So because we overloaded array operator like this, so these statements, so for this one, this will be the first operand called because it's calling objects, and 1 will be the second argument, which is index 1. Because index is 1, the member first, the reference of first will be returned. So the first member of the first, the value of first will be set to A, and same for this one. The index is 2, so the reference of this second member variable will be returned, so the second will be set to B. And after setting this, this one will also return the first, and this one will return the second. So if I compile this program, it prints A and B here because we set the first A here and second here. So by overloading these array operators, you can use your objects as an array, like as shown here. So let's go back to the slides. Okay, we just saw this example code. Okay, let me summarize this week's lectures. This week we have learned operator overloadings. We have overloaded unary and binary operators and function call operators and array operators and insertion and extraction operators. We learned that we could overloaded operator as a non-member and member operators. They both have their own advantages. And we also learned the friend functions. We learned that friend functions are commonly used for overloading operators, and it takes the advantage of overloading non-members and member operators. We talk about this using demo code. And we also learn about the friend class. Okay, that's it for this week. See you in the next week.